Friends, today we see about two-dimensional elements. So two-dimensional elements, it have two axes x and y. It have degrees of freedom both in the x and y direction in each nodes or each plane and rotational motions. So that is degrees of freedom. Two-dimensional elements are defined as given by three or more nodes in a two-dimensional plane, xy plane. The basic element useful for two-dimensional analysis, it's a triangular element. So triangular element, rectangular element, quadrilateral or parallelogram, plane stress and plane strain. The 2D element is extremely important for the plane stress analysis and plane strain analysis. Plane stress analysis is defined as to be the state of stress in which normal stress and shear stress directly perpendicular to the plane are assumed to be zero. Plane strain analysis is defined to be state of strain in which normal to the xy plane and the shear strain are assumed to be zero. Three-noded linear triangular element. The physical domain considers geometrically a two-dimensional domain, that is, area with uniform thickness, and the single variable can be one of pressure, temperature, etc. A scalar quantity, not a vector quantity. An example is the temperature distribution in a plate. At each point, there can be only one temperature. We consider such as area method with triangular element. Each triangular element has three nodes, one node at each corner. Let us consider one such element with coordinates x1, y1, x2, y2 and x3, y3. Single variable, for example, temperature at these nodes 1, 2 and 3 or u1, u2 and u3 respectively. If so, then the unknown single variable u, that is temperature at any non-nodal point x, y in the two-dimensional domain, can be expressed in terms of known nodal variable temperatures. So u1, u2 and u3. Let us assume the single variables can be expressed as, so u is equal to c1 plus c2x plus c2y. In order to find the three unknowns c1, c2 and c3, we apply the boundary conditions. So we can at x1, y1, that is u is equal to, displacement is equal to u1. So u is equal to c1 plus c2 x1 plus c3 y1. At x2, y2, u is equal to u2. Then u is equal to c1 plus c2 x2 plus c2 c3 y2. At x3, y3, so y is u is equal to u3. So u is equal to c1 plus c2 x3 plus c2 c3 y3. Writing the above three equations in the matrix form, so u1, u2, u3, that is a force vector, displacement vector is equal to 1 x1 y1, 1 x2 y2, 1 x3 y3, that is a matrix. Then force vectors, so c1, c2, c3 are. We need to find the value of c1, c2, c3. So c1, c2, c3 is equal to 1 x1, 1 x2 y2, 1 x3 y3, u1, u2, u3. So 1 x1 y1, 1 x2 y2, 1 x3 y3. In terms of inverse, so we can write this, that's equal to 1 by 2a, that is r1, r2, r3, so s1, s2, s3, x1, x2, x3. So where 2a is equal to ra, r1 plus r2 plus r3. So r1 is equal to, that is comma. So r1 is equal to xj yk minus xk yj. So gamma 2 is equal to, gamma 1 is equal to x2 y3 minus x3 y2. Gamma 2 is equal to x3 y1 minus x1 y3. So gamma 3 is equal to x1 y1 minus x3 x2 y1 rho beta, or we can simply say yes. So y2 minus y3 s2 is equal to y3 minus y1 s3 is equal to y1 minus y2. So x1 is equal to minus half x3 minus x2 minus x3. So x2 is equal to minus half x3 minus x1. Then x3 is equal to minus half x1 minus x2. A is the area of triangle. So C1, C2, C3 is equal to 1 by 2A. So R1, R2, R3, S1, S2, S3, X1, X2, X3. So U1, U2, U3. Submitting the values of C1, C2 and C3. N U is equal to C1 plus C2X plus C3Y. We get displacement U is equal to N1 U1 plus N2 U2 plus N3 U3. So N is 1 is equal to 1 by 2A R1 plus S1X plus X1Y1. Where I is equal to 1, 2, 3.